All right, we're going to be talking about perpendicular and properties of equality. This is our second section for today. And we're going to start off with perpendicular lines. Here's the definition of perpendicular lines. And you guys have your note sheets and you filled in the blanks. All right, and here's a picture to go with it. So let's talk about the picture and the words. Two lines are called perpendicular lines if they intersect to form right angles. The way you know it's going to be a right angle is because yours is very light right there. I'm going to actually make it darker, and I might even make it red. Many times when you see it in a textbook, it'll be red. It'll have a part of it, second half, to make it look like a square or a little nut on a right angle. The only way on your diagrams that you know an angle is right angle or it's perpendicular is if it has this symbol. If it does not have this symbol but it looks 90 degrees, it could be 89.2. It could be 89.7. You don't know that it's a right angle until it has that symbol. If it doesn't have that symbol, you cannot assume that it's a right angle. Okay? All right. Okay, we're going to do some problems on your homework. We're going to do numbers number 1 and 2. I'm going to give you two a chance who don't have those printed. You can draw these on the back. You've been reading the marks with congruent angles and segments. So you'll need to have these. If you don't have them, that's fine. Just turn the page over. Draw this. We're going to do number 1 and 2. It says list all information given by the marks in the diagram. Use the perpendicular symbol when necessary. And I'm going to show you what that perpendicular symbol is. These two only have perpendiculars. They don't have any congruence anywhere else except. So what angle is perpendicular in the first number 1? What angle is 90 degrees, I should say. Angle T is 90 degrees. But we need to say that something is perpendicular to something else. So I'm going to start off with TU. U, and I'm going to make it a segment, is perpendicular to what? QT. Or you could also call RT if you wanted to. You could say RT or RQ because there's the short one or the same one's long. It doesn't matter. You write whatever you want on your paper. I don't mind. It'll be the same. I'm going to do QT. Now, the symbol for perpendicular looks like this. It's an upside down capital T. So this sentence, because mathematicians love to abbreviate for their sentence, this says TU is perpendicular to QT. I want you to now try number 2. Something is perpendicular to something else. Give me just this either a little hand or an eye. Look at my eyes to tell me that you have written number 2 down. Something is perpendicular to something else. Got somebody who's done. Got another person who's done. Got another one who's done. All right, I got a third one because people are not writing down, so I assume that means they're done. Okay, so I'm going to start off with PQ because that's the top one right there. And the thing that we're looking at is that the little red L or the little red perpendicular mark there. And we use the upside down T to indicate perpendicular. As you can see, this symbol is actually, you're writing 2 lines that are perpendicular. Okay, PQ is perpendicular to what? QS or SQ. Okay, I don't know. Q seems like it should go first.
Does it matter which way you write that? Is it okay if you put QS and then PQ?
That is a fantastic question. If you would have put that backwards like this, you would have had the correct answer. Now, on your homework, the answer key might not have it both ways, but you need to realize that it is okay to write it both ways. Okay, because it is still a true statement that QS is perpendicular to PQ. They have to be yes. Yeah.
Do I have to the lines on top? Should they have the arrows on the end?
That's a good question. Help her out. What would it mean if there were arrows on the top?
There were lines.
If these were lines. So if you could have written lines, because they are lines, but mine says that the segment PQ and segment QS. So both of them would have been correct, okay? So if you would have put lines on them, you would have been correct. You actually might, I don't know what the answer key even says. I don't know if it says line or segment, but it would have been correct both ways, okay?
Because it has like the arrows.
Because the arrows, that line PQ is congruent to, perpendicular
the other
to line
one-
Q. They're both, it's true.
Yeah,
Both of them
but
are true.
The first one.
The
it would
first
have
of
to
them,
be-
it has to be just the lines and not, the segments and not the lines. That is correct. This one is a segment. This could be segments or lines. All right. Other questions? You're doing fantastic. All right. Now we're going to start talking about, I want you to get handouts for your properties, and which is also in your definitions, okay? Keep those out. We're going to talk about them. I want you to locate them. They do look like Amy's right here. She has them, and I have mine also just to show you. They look like this. If you don't have them, it's okay. You can just print them when you get home. But this is what they look like. We are going to talk about this first page. I've even said where they come from, 2.2 in the front right there, okay? These need to go in your postulate book. If you want to give yourself a little note on the side, put in postulate book or something.
Question.
Yes, ma'am.
It was at the end of our one of our lessons that we had to this week, but I only put in the ones that said either postulate or theorem.
I did that too.
Am I supposed to put everything
In
here?
this one, it's not a
Because
problem.
These look like formulas to me.
I understand. And so now that you know, these ones on this first page are properties, and you can put those in your postulate. Because we'll be using them for proofs. And maybe I should have called that the proof book, so that you know what to use for proofs, okay? All right, so this is what we're going to, these are all in there. You should have addition property, subtraction property. They might not even be in this order, but you should have addition, subtraction, multiplication, division. You should have reflexive. You should have symmetric. You should have transitive. You should have substitution. And you should have distributive property. And if you don't have distributive property, yeah, you do. You should have all of those, okay? Yeah, that's fine.
Substitution?
Do you have substitution on yours? Look and see.
No.
Okay, well, so we'll add it. I will be putting it up here. You can add it. You can add it on the back or the bottom, but you will need substitution you're going to use over and over and over, and if it's not on there, we will make sure it does get there, okay? All right. Are you ready?
They're going to be handwritten in our postulate book.
Those would need to be put in your postulate book.
In
And
the back or in the front?
in the front. In the front. Good question. All right. All right, so let's explain all these. The addition property, you have used the addition property a lot. You just don't realize it. This is the symbolic form of it. This says that if I have two things that are equal, and if I add the same thing on both sides, it will still stay equal. For example, if I had 3 equals 3, which is a true statement, if I add the same thing on both sides, I will still stay equal. You use this in algebra all the time when we add something to both sides. Jumps out every time. All right.
Help somebody, please.
There we go. That's what I was hoping for. Don't know why it didn't do it last time. All right. The subtraction property is very much like the addition property. It says that if we have something that's equal, but I subtract the same thing from both sides, it will still stay equal. We were doing that a moment ago. If I still have 3 equals 3, and I subtracted 1 from both sides, I will still get something that is true. I'll get 2 equals 2 on both sides. You use this all the time. You just didn't know the name of the property. We use it all the time. Multiplication property, we've done it before. If I have something that's equal and I multiply something on both sides, it will still stay equal. We've been doing that with algebra a lot. Very similar to the example that I've done with addition and subtraction. And now we have the division property. I want you to notice with the division property, I have slashes right there instead of the traditional division symbol with the line and the dot on top and bottom. This is the same thing as that division symbol, but many of our calculators, as you get in the upper levels, are going to start having slashes, and that'll be on your computer also. So this means I can divide both sides by the same number, and it still stays the same. You've been doing that for algebra forever.
Why, that's what you do the best.
Maybe there was 2 of them, and I've deleted the rest of them. Here we go. The reflexive property, these are new. You have never seen these before. Very likely you had the addition, subtract, add, subtract, multiply, divide, but these are new. These are going to seem extremely like duh, like no duh, okay? But geometry is in the realm of being to prove things. And so you guys that's what we're going to start, is using these stuff for proofs. And some of you have seen proofs in your life before. Some of you have never seen proofs before, and that's not going to be a problem. Reflexive is going to be super simple. It says that if you have some real number, that it equals itself. All right? You're going to be using this with lengths of segments, that segment equals itself. That seems extremely no duh. But we need to have it at times for what we're going to be doing, okay? Symmetric. You've used this many times. We used this a moment ago when we were doing this with perpendicular. You guys, we wrote one backwards and the other one, and Amy said, what if I wrote the QS first and I think it was PQ second? Is that okay? Yes, because it works out to be symmetric. It would be fine, right? So if I have something equaling, like x equaling 2, this is the most common thing we see, x equaling 2, it's the same as 2 equaling x, and I can turn them around all I want. Last one on this. No, there's two more. Transitive. I love the transitive property of equality. It's one of my favorites. I like this for cousins or for owing money, kind of like, but more with cousins. If A equals B and B equals C, then A equals C. So if I am a cousin to John and John is a cousin to Joan, then I am Joan's cousin. All right? There's other things in life that would translate for transitive property, but that one is used often. We're going to talk about substitution, and there are times when these two get intermixed with each other. All right, here's substitution, and you guys will want to write this down. Apparently, it's not on your list. It's not on your list. I'm going to give you some time to write this down. Give me a hands up or an eye, look at me, or something to tell me that you have gotten this all written down.
What are we writing down?
This is not on your notes list. On your list, you'll want to make sure, put a little note in there that's not on there, okay? It's not in those properties lists. If A equals B, then A can be substituted for B in any equation or expression. So if x equals 5, anywhere there's an x, I can put in a 5. You use that to substitute into expressions since probably back in 5th or so grade. So you've used substitution over and over and over. All right. Last one, the distributive property. This one I have a note to add this to your sheet, but it's the one that is there. I should have actually put that one on substitution. Let's bring it up here. You've probably seen the distributive property. It says I just take the A times the B and I get AB. I take the A times the C and I get the AC. We've done this many times, especially solving equations. We're going to use these today to start the process of a proof. And we're going to start that process of a proof with solving equations that you guys have been doing in the past. Let's see if we can get through all that without. All right, I don't know why it keeps jumping out. Here we go. So what we're going to do is we're going to start this thing with proofs. You're going to draw. You already have one probably on your page. Do you have one in there already?
On the note sheet?
On your note sheets? Yes. Go back to your note sheets now.
Yeah.
This is problem number 16. But on problem number 16, we're going to do this together with all those things. So I showed you, actually no, I'm sorry, my bad. We're going to now do some of your homework together. Instead of me putting an example on your note sheets, we're going to actually do some on your homework. So when you get your homework, you'll be able to see it. So we're going to do number 16. The instructions for 16 says solve the equation and write the reasons for each step. And so I want you to first get a chance to find number 16. And you two just write this part. And everybody's going to have to write this out. Okay? We're going to make it, and I would just make it, instead of a box, you can make it like a T. You just start up here like this. And you write.
Is it 2.216?
It's 2.2, number 16. That's correct.
Okay. That explains.
Right there. Okay? All right? So you're going to give yourself a T. Okay? We're going to solve this equation. The very first thing that starts out is number 1. And that is the original problem. K plus 6 equals, and I'm not going to have enough room if I'm not careful. I might have to scoot mine out a little. K plus 6 equals negative 12 minus 2K. This is the original statement that's given to us. We're going to solve it. This is going to get you used to doing proofs to see how everything works. You write the word statement on one side and reasons on the other. The very first reason is because this problem was given to you. So the answer is given. You always start with the given. What do I do to solve this first? What do you want to do?
Add the 12.
You want to add the 12 to the other side, okay? You do not have to show your work on this. You get to show what the next step ends up to being. So when I add 12 to this side, I'll be left with the negative 2K, and this will become 18. So step number 2 will turn into K plus 18 equals negative 2K. If you need to write it in, please feel free to do that, all right? If you need to make a little add 12 and add 12 in there, please feel free.
Are you allowed to like draw lines under it to separate it?
Yes, you can, especially, yes, you can if you need to. Now, the reasons are all of those properties that I just gave you, these. What reason did I just do? Did I do the
Addition.
I had added. Now, there is not enough room to write addition, property of equality. So, I would suggest that you have these easily flipped to. I am going to show you how to abbreviate. All right? And you need to have a number 2 over here so we know they go together. We're going to write addition, but we're going to abbreviate it. Add, addition. We're going to do property. And I'm going to leave it at that, addition property. Okay? If you want to, next to on your little sheet now, if under there you want to write add.prop to know how to abbreviate that. Mathematicians love to abbreviate, and there's not enough room in their little proof to write everything. Some books are going to say of equality. We're eventually going to have, these are not going to just apply to equalities, they're going to also apply to congruence later. So we're going to just call it addition property. All right? What do you want to do now? What's the next thing we need to do?
Minus the K.
Move the K to the other side. And when we subtract the K to the other side, what will it become?
Negative 3.
Okay, so we don't have to write the little step of what we did. We just have to write 18 equals negative 3K. What allowed us to do that? The subtraction property of equality. Now, I want you to be really careful. You have a subtraction property and you have a substitution property. You cannot abbreviate both of them because I won't be able to know if you mean subtraction or substitution. So I am going to let you abbreviate one of them, and that's the subtraction one. So we're going to call it sub-prop. And you can, on that little sheet over there, on the subtraction property of equality, if you want to put the little abbreviation, sub-prop. That way you know how to abbreviate it.
For subtraction, couldn't we just do SUB and put a T after it? So
You could. No, because substitution is the same thing.
Oh,
Yeah, so it's kind of, yeah.
okay.
Yeah. Isn't that crazy? The sub and substitution. I guess one has an S.
Well,
Substit.
this is
And one's
subs.
t. Yeah,
This is subs and this is subs.
yeah. All right. Now, are we done? Have we solved this equation?
No.
We need to do what for this equation?
Divide.
Divide by the 3. Do negative 3, by the way. Negative 3 divided on both sides will become the last step will become K equals -6. What property did we use for that?
Division.
Very good, division. So we can do the same thing, div prop. Division property, okay? It's one of my pet peeves actually when someone reads abbreviations that they just say div prop. When you read it, you still have to say division property. So that's just div prop. I think that sounds funny. But okay, so what we did is you solved the equation and you gave the reasons for each step with the properties that we just did, okay? The ones you're going to use the most are multiplication, division, substitution. No. Addition, subtraction, multiplication, division, and we're going to do distributed property next. Because we're now going to move into number 19. Number 19. I did not write up here for you what's supposed to go there because we can do it together. You're going to give yourself a little T-chart again. On the left side, the statements. And reasons. What was the very first thing that we write over there?
The whole equation.
The whole thing that we start with, yes. 84 equals 3, 7a plus 7. And the reason?
It's given.
Given. Okay, that is what was given to you, okay? Not because my mother said so or my mother's making me do this, because it's given. All right. Number 2, what are we going to do on this first one? What are we going to just start?
3 times 7.
Yes, we're going to use the distributed property. I'm actually telling you the answer right now of what we're going to do. We're going to do those two together and those two. We don't have to write the little step in there. We can put it together. We got 84 equals
3 times
21a plus
21.
21. Reason?
Distribution.
Okay, dist prop. Yes, we're going to do distributed property. D-I-S-P property. Fell off the screen.
G-I-S-T, right?
T. Yes, thank you.
Do you have to put the T or is it okay to just put dis? Or is there...
We could do DP. How about that? No, I'm sorry. We got to at least, give me 4 letters, just like I did. Oh, I suppose. You can give me DIS. Yeah, I probably will be all right.
Subtract the 21 from the 8.
You want to subtract the 21, this 21, not the 21A, but this one over here?
The 21.
Okay, you want to subtract the 21 to the other side. Okay, so number 3, when we have 84 minus the 21, what does it become?
63.
Yes. Is it? How much?
Wait. Well, it's 84 minus 21 is 63.
63? So 63 equals 21A.
Okay, the subtract part, or sub prop.
And I'm letting you do just the sub part, right? Because it's subtraction property.
Sub prop. Div prop.
I'm going to let you do the last step by yourself. Give me this hands up or an eye or something to tell me you have finished that problem. I've got
Can you hand me
3.
the brown bag over there? That's where my calculator is.
Yes. You guys can share. I've never gotten to teach in bare feet before. Just realized that because I'm at home. When you're teaching in a classroom, you can't be in bare feet. All right, so we divided both sides by 21. What is 63 divided by 21?
3.
So A equals 3. So number 4, the reason we did that was
Division.
division,
Or div prop.
div prop.
You should
Amy loves div prompt. DIVI. I should make her get one more letter.
You shouldn't have told her that you don't like that. 'cause now
Div prompt.
do it.
She's gonna start doing
Div
div prompt. All right.
I'm gonna be stuck on this.
Questions. Please ask me questions. All right.
Question.
This is the very beginning of proofs, okay? You have been doing these for so long that that these ones aren't intended to be difficult, but they're intended to get you into the idea that what I'm doing, I have to justify what I do, okay? I have to know what I'm doing here, and then I'm going to justify my answer with reasons for the things that I do. All right. This will be your very first lesson. The very first, when you go home and do your homework, this will be what you do. You'll be talking about perpendicular. You're going to, the assignment will just be to name things that are perpendicular, like we did on those couple assignments. And then you're going to be doing some proofs. You're not going to just solve them now. You're going to give your reasons for your answers. And your start of the proof process, we have statements on one side, reasons on another. Okay. Geometry is full of proofs, especially first semester. Second semester, they'll trickle down to a little by little by little, be none. But first semester, we're going to do lots of them. Some people hate them. Some people don't mind them. Nobody finds them easy, okay? And I'm telling you that so that when you get home, this first part might not be really hard, but it might be a little difficult at first for this new part. But when we get to the next ones, none of them are easy. And I'm telling you that so that when you get home and you're stuck on them and you go, I don't understand what to do, that you won't think that you're dumb, okay? Because nobody, when they first learn how to do proofs, go, wow, this is simple. Nobody does that. So when you're having difficulties and you're at home, I want none of you to believe that there's something wrong with you because this is hard stuff, okay? We're starting the process and we're going to go through them and I'm going to be doing bunches of them with you.